ABC. I'm going to go over some multiple choice questions from the practice AP that hopefully all of you did over winter break. And I'm just going to say right off the start that numbers 6, 20, 25, and 90, I'm going to go over at some point over the next couple of weeks. Just like little bits and pieces that I want to cover in class. So again, that's 6, 20, 25, and 90. Those are little bits that we'll go over, certainly in January. Or they're on differential equations, and we haven't covered that yet, so don't worry about those. I'm going to try to address, I think, all of the ones. There's a lot of overlap that you guys wanted to look at here. Okay, so the first one, this is going to be very much kind of random, so feel free to skip around. I'm going to go in order, but there are a lot of them. Okay, so here's 11. That's our first one, and that talks about some accumulation function f of x, which goes from 0 to x of 2t cubed minus 15t squared plus 36t dt. Okay. And so the question is, on which of the following intervals is the graph concave down? So concave down, concavity, obviously we want to think about f double prime. And think about, if to find concave down, we want to find out when that thing's negative. So, so concave down is really asking when is f double prime negative, right? That's really what we're asking. And so by the fundamental theorem, right, we know f double prime is just this, right? It's just that exact function replacing t with x, right? And therefore we can just take the second derivative right away. So that's 6x squared minus 30x plus 36. Okay, and so we want to know when this thing's negative. So let's find where it's 0. And I'm going to divide by 6. So I'm going to get something that looks like this. So obviously this thing factors nicely like this. And, you can verify that if we make a sign chart, here's 2, here's 3, and we're going to be positive over here. We're going to be negative in the middle, and we're going to be positive over here. So it's between 2 and 3 is what I would say. Okay, so that's 11. Next one that you guys wanted to see was 12. So 12, like I said, please skip around. I'll try to sort of start a new page, and so you can sort of see what I'm working on. And we're trying to find out which of these limits is 0. So number 1 was f of x is ln x over x to the 99th. Number 2, right, was e to the x, f of x equals e to the x over ln x. And number 3 was f of x equals x to the 99th over e to the x, okay? And so all of these guys, right, we can L'Hopital them all we want, right? That's totally fine. We're really just concerned with, hey, does the bottom grow faster than the top? And so let's think about all of these functions, and let's actually just rank them, right? We have ln x, we have x to the 99th, and we have e to the x. And let's think about how fast they grow, right? ln x is obviously the slowest because its graph looks like this, right? Slow. So as x, it does go to infinity, right? As x goes to infinity, but it goes slowly, right? It increases very slowly. X to 99, that obviously looks like this, right? It goes up quickly. We don't necessarily know what it's shaped like, but e to the x also goes up like this. So our basic question is, which one grows faster? Which one grows faster, okay? And if we were to L'Hopital these guys, right? We'll examine number 3 kind of closely. So let's look at the first one. So the limit as x approaches infinity of ln x over x to the 99th, right? This thing's obviously 0, right? If we wanted to L'Hopital it, right, we'd end up with something like 1 over x over 99x to the 98th, right? And you can see, right, that this thing, the x is going to go down there, and we're gonna end up with 0. This thing, right, is a slow grower over a fast grower, so obviously it approaches 0. So we know that this one's correct. The second one we know is incorrect, right? E to the x grows fast, ln x goes slow, right? Similarly, if we wanted to L'Hopital it, right, we'd be left with something that looked like this, right? If we L'Hopital this guy, we're going to be left with e to the x over 1 over x, right? That x is going to go upstairs, and this thing either dne or infinity, right? Or either one. So 2 is not right. 2 is not right. So I guess we've narrowed it down to it either has to be a, which is 1 only, or e, which is 1 and 3 only. And let's look at 3 now. So if we wanted to L'Hopital 3, that would be a fairly tedious process, right? Because we have x to the 99th over e to the x. And if we L'Hopital that once, we're going to get 99x to the 98th over e to the x. And as big as this guy seems, he eventually, if we do this 98 more times, is just going to be a number up there, right? And then it's going to be 0. E to the x is always going to be e to the x. So this thing actually grows faster than x to the 99th. And if you think about plugging in a big enough number for e, you could think about that. But this thing also equals 0. So I believe the answer should be e. Both of them work. All right, let's move on. 15, I might do this one kind of fast. 15 was asking us to use some chart that said f of 3 is -1, g of 3 is 2, f prime of 3 is 5, g prime of 3 is -2, and it asked us to find k prime, where k of x is f of x over g of x, right? So we just needed to apply the quotient rule. So we really wanted g f prime minus f g prime over g squared, right? So this ends up being something like 2 times 5 minus -1 times -2 all over 4, right? Which ends up being 2 if you do that out. Okay, so that one pretty good. We already said we're going to cover 20 later. 22 is the next one I gotta do. 22. So this says that we have a continuous function for all real numbers, and the average rate of change on this interval 6 to 9 is -3/2, and we're told for 6 is less than c is less than 9. There's no c such that f prime of c equals -3/2, right? So what does that tell us? That says, hey, this thing does not follow the mean value theorem. It does not follow the mean value theorem. So we need to think about what is possibly going on for it not to follow the mean value theorem, right? The mean value theorem says that, hey, the average rate of change on some interval would at some point we would have to be that average rate, right? So if this does not follow it, that's kind of a problem. So let's go through the answers one by one. So the first answer is saying that this is saying that we'll write them out. So this guy has this expression on the left. And we're saying which of these must be true. This could be, any of them could be true, but this one isn't necessarily true, right? Why is A not necessarily true? Well, this expression on the left, this is the average value of f, right? That's what that expression is. And of course, we know nothing about that. So we definitely can't say it is true, right? The next one says that the integral does not exist. Does not exist. Well, we know that f is continuous, right? And if f is continuous, we can certainly find the area under it, right? So this thing is not true either, right? F is continuous, and given in the problem. Therefore, we could add areas, right? We could add areas because we can draw it without lifting up our pencil. C is saying this thing, whatever this is, equals negative 3/2, and then I hope you guys recognize this, right? This guy's the average rate of change. Average rate of change, right? And that certainly doesn't have to be sorry. No, this is not the average rate of change. My bad, right? If this were a minus there, this would be the average rate of change, right? This is just finding the average at 6 and the and 9, right? So this is averaging slope, my bad there, at 6 and 9, right? And that definitely doesn't have to be this thing. We're saying the average on the whole interval has to be that guy. Okay, my bad. And then D says f prime of x is less than 0 for all x. Well, we don't know that, right? This thing could go up and down like crazy. We certainly don't know that. So who knows? It doesn't have to be true, right? So that leaves us with E, which better be right, which is f is not differentiable. Okay, and this one is the correct answer, right? Because we know that if it were differentiable, then it would have to subscribe to the mean value theorem, right? Then we would have to have some c where that f prime of c was negative 3/2. So E has to be true, right? That there must be some corner or something here that makes this not differentiable. That's the only way that we can avoid that negative 3/2. Okay. We're going to keep rolling on. 23